Hello, welcome back to online class. In this part, we can discuss some MCQ questions from your chapter Redox reaction. I think the questions are given to you. Okay, so moving to the first question. The process in which oxidation number increases is. The choices are reduction, 2 hydrolysis, 3 oxidation, 4 decomposition. So the reaction or the process in which oxidation number increases. We know that the increase in oxidation number, the process is known as oxidation, right? Yes. So the choice is 3. Okay. So moving to the next question. The oxidation number of phosphorus vary from. It is already mentioned, right? Oxidation number of phosphorus is varied from. Phosphorus can show a wide varieties of oxidation state from -3 to +5. Not only phosphorus, the group 15th element can show from -3 to +5. It is discussed, okay. It is already discussed in the first part, I think. So the choice is A, which means 1. Moving to the third question. The oxidation number of iodine varies from. Same type of question. Iodine is a halogen, so halogen except fluorine all have a variation of oxidation number from -1 to +7. Okay. The next question. So the choice for the third question, -1 to +7, the choice is 2. The next question. White phosphorus react with the caustic soda to produce pH3 and NaH2PO2. This is an example for oxidation, reduction, disproportionation, neutralization. These all are direct questions, you know. It is discussed. White phosphorus on treatment with the caustic alkali. Ready? Forms phosphine and NaH2PO2. Ready? And this is an example for, you know that phosphorus is before the reaction 0 and after the reaction -3 and +1. So phosphorus undergoes reduction, phosphorus undergoes oxidation. So this is an example for disproportionation reaction. Disproportionation reaction. The choice is 3. Okay. The next question. Oxidation number of oxygen in O3 molecule. O3. O3 means what? Ozone, right? So ozone is an elementary state of oxygen. It's an elementary allotrope of oxygen. So the oxidation state for any element in its atomic state, or for any atom in its elemental state, oxidation state will be 0, and that is a rule which is already discussed, right? Yeah. Okay. So the choice is 0. Oxidation state of oxygen in O3 molecule is 0. The choice is 0. Choice 1. The next, oxidation number of carbon in CH4, CH3, Cl, CH2, Cl2, CH respectively. So there are a lot of examples. CH4, CH3, Cl, CH2, Cl2. Ready? CHCl3, CCl4. Okay. Listen. For this CH4, which one have greater electronegativity, hydrogen or carbon? What about the electronegativity order? Electronegativity of chlorine, that is greater than carbon, and the carbon which is greater than simply hydrogen. So +1 into 4 hydrogen. So this carbon should offer -4. Here chlorine -1, because comparing to carbon, chlorine have more electronegativity. And 3 hydrogen may offer +3. So the remaining charge is +2. Ready? And that must balanced by carbon by providing -2. What about here? It is minus 2. Here it is plus 2. So carbon have a charge of 0. Ready? What about here? Here 3 chlorine minus 3 and a hydrogen plus 1. So the net charge is minus 2. So carbon have to balance it by offering plus 2. Here 4 chlorine minus 4 and a single carbon is able to balance it. So he should offer plus 4. So what about the question? The question is the oxidation number respective, you have to write the oxidation states of carbon in the respective order on the given order. So it is minus 4, minus 2, 0, plus 2, plus 4. The choice is 1. The choice is 1. Okay, fine. Moving to the next question. Listen, moving to the next question. The next question, that is, listen here. The next question, the chlorine in plus 3 oxidation number in. So there are 4 different compounds of chlorine is given, and you are asked to find in which compound the chlorine exists in plus 3 oxidation state. Okay, let me write that compounds. The compounds are question number 7. The choices are HCl, HClO4, Cl, ClF3. Okay. What about the HCl? What about HCl? HCl hydrogen is in plus 1, so chlorine should offer minus 1. HClO4, oxygen part offer minus 8, right? And hydrogen part offer plus 1. So the chlorine that is in 0 oxidation state because the chlorine is an element. And what about ClF3? In ClF3, fluorine have more electronegativity than chlorine, so minus 1 into 3. So fluorine offers minus 3, so chlorine should balance it by offering plus 3. Okay. So it is clear that the chlorine which is in plus 3 oxidation state is your ClF3. The choice for ClF3. Okay. Moving to the 8th question. The 8th question, that is, given that the oxidation number of sulfur is minus 2 and equivalent weight of sulfur is equivalent mass. We know that equivalent mass is equal to molar mass divided by n factor. They said that sulfur is in minus 2 oxidation state. So this is a species which is said to be an anion. So the n factor of that anion is the negative charge of that anion. So molar mass, everybody know that sulfur have 32 the molar mass. So the n factor, that is 2 because it is in minus 2 oxidation state. Okay, so the equivalent mass of the sulfur will be 16. Okay, and this is the 8th question. 9th question. A reaction between zinc and iodine. Zinc iodide is formed. So we have zinc iodine. And what happened means ZnI2 formed. Okay. Then your question is, which being oxidized? Zinc ion, iodide ion, zinc atom, iodine. So 0, 0. And now your zinc is in plus 2, iodine is in minus 2. So zinc undergoes oxidation. Zinc atoms undergoes oxidation. And iodine atoms undergoes reduction. So which is being oxidized? So no doubt it is zinc atoms. Okay. The next question, listen. That's a reaction. Question number 10. In the following reaction, the following equation, the equation is 2Br2 plus 6CO32 minus plus 3H2O gives 5Br minus plus BrO3 minus plus 6 HCO3 minus. Fine. So in this reaction, bromine is oxidized, carbonate is reduced. Bromine is reduced, carbonate is oxidized. Bromine neither reduced nor oxidized. Bromine reduced as well as oxidized. What about the case of carbonate? Here the carbon which is exist in both carbonates, okay? We know that in carbonate the oxidation state of carbon which is in +4. Moreover, in bicarbonate also the oxidation state of carbon which is in +4. So before reaction it is in carbonate and after reaction it is in bicarbonate, were both having same oxidation state +4. So here carbonate or the carbon which undergoes neither oxidation reduction. Okay. Then what about the bromine? Bromine now before the reaction 0 and after that it is in -1 and BrO3 it is in +5. So bromine is reduced, bromine is oxidized. Okay. So we can choose the choice 4, that is bromine oxidized as well as reduced. Okay. Moving to the 11th question. Listen. The 11th question, that is in which reaction there is a change in oxidation state of nitrogen atom. So simple question. The choice A, 2NO2 gives N2O4. And choice B, which means 2NO2 plus 2H2O gives HNO3 plus HNO2. Choice 3, NH4OH on decomposition forms NH4 plus plus OH minus. Choice 4, N2O5 plus H2O gives 2HNO3. Our question is, in which of the following the oxidation state of nitrogen is changed? So we know that here the nitrogen is in +2, here also +2. So here there is no change in oxidation state, it is simply a dimerization. And NO2 is said to be mixed anhydride because the NO2 which is in +2 upon hydrolysis forms two different acids, nitric and nitrous. So it is clear that the oxidation state of NO2 from +2 to changes from +2 to +5 and +3. So here the oxidation state of nitrogen changed, okay, and here the nitrogen -3, here also in -3, okay. So there is no change. Here the nitrogen +5, here also nitrogen +5. There is no change. Okay. So reaction where the change in OH is observed in the choice 2. 12th question. When iron is added to copper sulfate, copper is precipitated. It is due to. So when iron is added to copper sulfate, what happens? We know that iron is a metal which can displace copper from the electrochemical series, okay, and I'll describe you the detailed of your electrochemical series because our next chapter is electrochemistry, okay. So everything about electrochemical cell, electrolytic cell will be discussed in the, okay, so don't worry. And by having a brief idea about your electrochemical series, then only you can say that copper can or copper is displaced by iron. So we know that or you should know that iron which can displace copper. So if it displaces copper, what happens? Copper will be free. So copper which exists as a precipitate. Okay. So question is, when iron is added to copper sulfate solution, copper is precipitated. It is due to the choice A, oxidation of Cu2 plus, choice B, reduction of Cu2 plus, choice C, third one, hydrolysis of copper sulfate, choice 4, ionization of copper sulfate. So here what happened means, here the copper which is in +2, right, and when it become a precipitate, it becomes 0. So what happens? Copper is reduced. Copper is reduced. Okay. So reduction of Cu2 plus ion. So the choice 2, which is a perfect one for this case. Okay. Moving to the next question, and I can write here. Okay, write it here. The next question, which of the following reaction involves oxidation and reduction? The first reaction, that is NaBr plus HCl. You know that the forms NaCl plus HBr. Okay, acidification of salts are not a redox reaction. There is no change in oxidation state, right? Yeah, +1, bromine -1, hydrogen +1, chlorine -1, sodium till +1, chlorine till -1, hydrogen +1, bromine -1. There is no change. Okay, what about the next case? The next case is H2 plus Br2 gives 2HBr. This is not an hydrolysis or a acidification of salt. This 0 from +1 to +1 -1. So this is a redox reaction. Ready? And the third and fourth, the third one is also acidification of a salt. The salt is AgNO3 and it is acidified using another acid, and the forms AgBr plus HNO3. So there is no change. These all are exchange reactions. Okay. Moreover, the fourth one, this is not also a redox reaction. You can find it. Okay. The fourth one is acidification of a salt. Here also exchange takes place and no redox reaction. So you can choose the choice as 2. Which of the following involves reduction of copper? Reduction of copper. Okay, the first choice, that is Cu plus half O2 gives Cu2O. Sorry, CuO. And we want to find the reduction of copper. This is the addition of oxygen to copper. So this is oxidation. This is simply the oxidation of copper. We know the definition. The second one is, that is Cu2 plus 2I minus gives 2Cui. Here the copper is in +2 and now it is also in +2. So this is not a redox reaction. Even this is not a redox reaction. Okay. What about the next? CuCl2 plus 2F minus gives CuF2 plus Cl2. What about here? Copper is in +2 till the copper is in +2. This is simply a displacement reaction. Okay. However, the oxidation state of anions are changed, but your copper, which is a spectator ion, it means its concentration remains unchanged. And what about the final one? CuO plus H2O gives CuOH twice. Okay. Ready. I'm sorry. There is a small problem. Here the copper is in +2. Here the copper is in +2, right? Yes. And with the CuI, the copper is in +1. Agreed? So there is a reduction. Okay, here also, which is in +2, no reduction. So the choice, we can choose it as 2. 2 is the choice. Okay. The next question, that is the 15th question. Listen. The 15th question, which one of the following is the correct match? Okay. The first one, chlorine only a reducing agent. Chlorine only a reducing agent. Is it okay? Chlorine is in zero oxidation state. Ready? So it can extend its oxidation state up to +7, moreover to -1. So it can act as oxidizing agent and reducing agent. So this is a wrong statement. What you are asked to find? The correct match. So this is not okay. This is a wrong statement. The next question, HNO2 only oxidizing agent. Only oxidizing agent. No. And I'm already discussed the topic, the prediction of oxidizing and reducing in the first part. I think you know that. Okay. So here the nitrogen, which is in +3 oxidation state, and nitrogen can extend it up to +5, and nitrogen can extend it up to -3. So it can act as oxidizing agent as well as reducing agent. So this statement is also not a correct match. Third one, HNO3, both OA and RA. HNO3 can act as both oxidizing agent and reducing agent. It is also false because nitrogen is in +5 in HNO3, right? So it never extend its oxidation state to higher. It can extend it into -3. So it only act as an oxidizing agent. Okay, ready. And what about the next? SO2 both oxidizing and reducing. SO2 both oxidizing and reducing it. That's perfect because sulfur is in +4 in SO2, right? So it can extend into +6 and it can extend into -2. So when it extends into +6, it become a reducing agent and oxidizing agent. So it can act as both oxidizing agent and reducing agent. Okay. The next question, the oxidation number of sulfur in H2S2O8. It is already discussed in your theory section. H2S2O is Marshall's acid. Okay, H2S2O8, Marshall's acid, and this is an example for pseudo oxidation state and having 2 peroxide linkage, and there is 2 sulfur which all are in +6, right? It is discussed. And you know that the structure is something like this: S double bond O, peroxide disulfuric acid, Marshall's acid. -2, -2, -1, -1. So +6. Like that, this also +6. It is discussed already. Okay, moving to the 17th question. 17th question, and the question is, which one of the following has a lowest oxidation number of iron? Okay, there are some compounds. The first compound is, you know, that Mohr salt, FeSO4.NHSO4.6H2O. This is said to be Mohr salt, where the iron which is in a ferrous form. And you're asked to find in which of the following compounds where the oxidation state of iron is least. Fe2O. So a rare compound where the oxidation state of iron is +1. And the next is KFeF4CN6 times. And you know that 4 potassium can offer +4. So this coordination entity having a charge of -4. Where the 6 cyanide offers a charge of -6. So this one should offer +2. You know that. So iron is in +2, right? What about the fourth one? Fe2O3. Fe2O3, you can easily calculate it as +3. So in which of the following compounds your iron have lower oxidation state? If it is in Fe2O, right? Ready. The next question, that is, phosphorus has a oxidation state of +3 in. Phosphorus has a oxidation state of +3 in. Phosphorus has a oxidation state of +3 in. There are given some compounds. Okay, the first one, orthophosphoric acid, that is H3PO4, and you can easily calculate it as +5. We want to find the phosphorus oxidation state is in +3. And the next one is phosphorus acid, that is H3PO3, and you know that this is -6 and this is +3, so this should offer +3. So this may be our choice. Okay, let's have a look into another category, metaphosphoric acid, that is H3PO3. This having a -6 and this having a +1, so this should offer +5. The next, pyrophosphoric acid, H4P2O7. So this having a -14 and this having a +4. So here the part is +10. So 2 phosphorus have to offer +10. So each one offer +5. Ready. Okay. The next question, I think it is discussed in the theory. The brown ring complex compound formulated as. The brown ring complex is formulated as like this. Okay. Then what is the question? The question is oxidation state of iron. We know that this is in +1 because the SO4 hull having a charge of -2, so this entity having a charge of +2, and this is a nitrosyl ion 0, and water 5 water molecule of a 0. Sorry, this is not a nitrosyl ion, this is a nitrosodium ion +1. So hence iron should offer +1. Okay, I think it is discussed. Ready? The 20th question. The oxidation number of chromium in CrO5. They all are discussed. Oxidation number of chromium in CrO5. We know that CrO5 have a butterfly-like structure, and the oxidation state of chromium is +6. Okay, it is discussed in the detailed pattern. Next, in which of the following oxidation number of iodine is fractional? So there are some compounds of iodine, and you should find in where the oxidation state of iodine is fractional. Okay, by having a look itself, we can find it. The second one is having an oxidation state of fractional, because here the iodine +7, here the iodine, we know that iodine is in a paradox oxidation state -1/3, here +5, here +3. Okay, move to the next question. Which of the reaction, the next question, the question number 22, which of the reaction involves neither oxidation nor reduction? Neither oxidation nor reduction. The first one, conversion of chromate to dichromate. And the second one, conversion of chromium to CrCl3. The third one, KMnO4 to MnO2. So you should find a choice where there is no change in oxidation state, or there is no reduction or oxidation. Fe to Fe2O3.xH2O. So it is clear by having a look itself. Okay. So no oxidation reduction, that is your pair. You know that the dichromate, the oxidation state of chromium is in +6. Sorry, this is chromate. Chromate having also +6 oxidation state of chromium, and dichromate having also +6. And chromium 0, now the chromium +3. Potassium permanganate, the manganese is in +7, and here the manganese is in +4. Iron +0 and Fe2O3 +3. So it is clear that there is no change in oxidation state for your chromium. So there is no oxidation as well as reduction. So your choice is 1.